Good morning, dear students.
Good morning, sir.
Yeah, very good, Arpita. So we'll start today's class in exactly 10:50 now. We'll start right away. Arpita, after my class, so would you like to take up the right?
Yes, sir.
Yeah, thank you. So, yeah. Yeah, I've shared my screen. Okay, it's exactly 10:50. We'll start our class now. Okay. Right. So the agenda for today's class is comparing MapReduce with other systems. Other systems, majorly RDBMS. Yesterday, we discussed that big data can be very efficiently stored on HDFS, Hadoop Distributed File System, and um, analyzed big data. Once it is stored, it is analyzed using MapReduce. So there are a couple of questions normally come to our mind, and of course, many people have already asked in various conferences, international discussion forums, that how MapReduce is better than the RDBMS or any other system. So that is what we have to consider, discuss in today's class. So comparing MapReduce with other systems. So the approach taken by MapReduce may seems like brute force approach. Brute force. So apply in various places, that is divide and conquer. Brute force is divide and conquer. So you do the process parallelly at various places, and finally the results you can bring it down to narrow it down to only one. So one best example that you have already seen in brute force is uh, the divide and conquer, that is merge sort, which you have already studied. So what you'll do first, you'll split the array into various parts, and finally you sort it, bring it to one system. So just like that, the MapReduce approach is also same. First you split and try to execute or start processing one by one until you get the final result. So that is what the concept is all about. And observe, MapReduce is a batch query processor. Batch query processor. It will never execute one by one. It will collect a set of statements and executes the set of statements at once. And it has the ability to run an ad hoc query. Ad hoc query means the query which is not a regular one. You can ask very much different, like very much joint oriented, or very much like joints, and you can think of projections, sort of unusual queries. We call it as ad hoc queries against your whole data set, and of course get the results in reasonable time. Easy. Don't mute yourself. Maybe Kindly mute. Yeah, I think somebody has, by mistake, they have switched on, and of course I muted them all, right? Okay, so that's about MapReduce. MapReduce takes the entire process in batch, and it can able to handle ad hoc queries, um, on the data set as a whole, and results are reasonably transformable. It's very quick also. So compared to any other system, very quick. So during course of my research, I had one problem. Normally, that was a query search we used to do. So we had almost 84 lakh plus records, and I tried the same thing with 8 GB RAM on RDBMS, that is on Oracle. I tried so searching of the same data. So it took almost 22 seconds. Sorry, 28 seconds. 28 seconds. And I tried the same thing with MySQL. MySQL took almost 40, 46, 47, almost double time of Oracle. And later I tried with MapReduce, same concept, where I used Hive as the database. Hive is a database just like RDBMS. So Hive database, I stored the data, and I tried. You believe it or not, I could able to get it within 11 seconds. The same operation, same data set, same set of query. I executed. I got it within 11 seconds. So that's my one of the personal experience that I have. And meanwhile, uh, when we consider MapReduce, it changes the way you think about data and unlocks the data that was previously achieved on a tape or disk. Normally, I inquired later why this MapReduce is faster. So when you are working with RDBMS, what you used to do, you used to read the data, you used to move the data from your database to the program, and program used to search, and again it used to go to data, bring the data, search again, bring the data, search again, bring the data, search again, bring the data to the internal memory, that is RAM, and search again, bring the data to the RAM, search again, bring the data to the RAM, search again, bring the data to the RAM, search again. So this was done in Oracle. It was almost taking 28, 26 seconds. Later I found that in MapReduce, the data never used to move. Only programs, map function used to go to all the computers clusters where the program was stored, the data was stored. So, and there actually the searching took simultaneously, and results we could able to get it. And as the number of maps increases, as the number of
India ramps up coronavirus testing, acquired 6.5 lakh testing kits from China. Apex Medical Research Body ICMR rejects the claim that India.
Okay, I think somebody has muted. Okay, kindly please hold your thing. So when you are on this one, you unmute. Okay, so mute only when you are, want to talk something, you unmute. Okay, right. So I was just talking about how exactly map and reduce was generally working. So map functions used to go to the place where the data is present. In our traditional system, data used to move to the program place, but here map the programs itself, it used to go to the data place, and it changes the way you think about data and unlocks the data that was previously archived on the tapes the same way. Yeah. And it gives people an opportunity to innovate with data. So you can think of various innovative programs, parallel programs you can write on this big data that are being stored. So MapReduce is a different kind of programming where you had to think parallel programs. You had to think in such a way that the program should run parallelly across multiple computers. So there are a couple of examples. Mail trust, Rackspace, mail division uses Hadoop's entire MapReduce for processing their email logs. I have a small example. So Google, even today, it uses this MapReduce. They never store your email data in databases. They always store this data in a NoSQL database. Email data, all email data, so many thousands, lakhs of emails are being exchanged in a second in Google Gmail. And for all those Gmail lakhs of transactions, so they use MapReduce. And you never found the server busy from Google server. You know why? They use MapReduce. Their MapReduce program used to just check whether your mail is a spam mail or not. It will check whether the message what you sent is a spam message or not. That's the main job. That's the main job. So in order to just do that, they are using MapReduce. So it's so quick. As soon as you get mail, immediately it will segregate whether it is a spam mail or not, just for that division. So they are using MapReduce, and they are processing this email logs very much. They are analyzing, and MapReduce is compared with other systems like RDBMS. So very much required. Many people they still work on RDBMS very much. Database applications are still running on RDBMS, and grid computing is another renowned technology that we are dependent on. And if you want to suddenly move from RDBMS, you want to suddenly move from grid computing, it is not so easy. People will ask thousands of questions, how better it is, how good it is, and all those things. And not only that, they have another concept called voluntary computing. Voluntary computing is another very, very interesting computing task that are successfully done at USA, and of course NASA USA, and of course that is also compared with MapReduce. Now we'll discuss in detail the comparison with the RDBMS. First and foremost, so the question arises is why can't we use databases with lots of disks to do a large-scale batch analysis? What is wrong? What is wrong in handling RDBMS? Why MapReduce is needed? So that is the major question posed by most of the user community. They have asked to MapReduce developers. So the answer is, to these questions come from another 10 trend in the disk drives. The first one, the seek time is improving more slowly than transfer rate. Seek time, I think in OS you have already studied. seek time is the time required to read the data from your disk. So that is very much improved than transferring the rate. So, sir, why transfer? Why you are comparing seek time with the transfer rate? See, in a traditional system, I have already said. In traditional system, what you do, your data is transferred towards program. But in MapReduce, the program used to come to data. So the reverse way. It is the reverse way where the program used to come to data. That is in the case of MapReduce. So program transmission is very less. So transfer time of program is very much less compared to the entire movement of the data. So certainly what happens, the seek time will improve, and seeking is the process of moving data's disks heads to a particular place on the disk or read or write the data. So that is much slower than transferring of the entire data. Okay, and not only that, MapReduce characterizes the latency of the disk operation, the time delay. So, whereas the transfer rate corresponds to the disk's bandwidth. So, all these things certainly you compare with the RDBMS. RDBMS is totally, program oriented, whereas MapReduce is data oriented. So data is moved there. Data is not moved in MapReduce. Only programs are moved. But in RDBMS, data is moved, programs are not moved. So when more data is moved, what happens? Definitely your latency of disk operation will goes up, and your program becomes much more slower. So your output, what you achieve, is much more slower. And if the data access pattern is dominated by the seeks, it will take longer to read or write large portion of data set than streaming through it, which operates at transfer rate. This is very, very, very important point. See, when your seek time, latency, your transfer rate increases, automatically what happens, your program output time also increases, and finally you will get the output at a very late. So it will take more time, you will get the answer very late. So that is one important reason why MapReduce is faster. And on the other hand, for updating a small portion of records in a database, the traditional databases use a B tree, the data structure that is used in your relational databases, which is limited by rate it can perform the seeks. So since the B tree operation will also take a lot of time, so it is not suggested, and it will not accepted by most of the people. So their time consumption is more. Of course it works well, but it's it consumes more time. It consumes more time. So that is what we consider. And for updating the majority of databases, B-tree is less efficient than MapReduce. It is proved. And B-tree, certainly it uses sort and merge to rebuild the entire database, but the MapReduce is not like that. It is having inbuilt procedure, so that itself will maintain the entire operation in a very systematic way. So with all these points, we can certainly write MapReduce is better than RDBMS. It's better than RDBMS. In the examination, they will ask this question. Okay, so why MapReduce is preferred than your RDBMS? Give some technical points. So certainly you can write this. And the same thing we have compared in a table form. So the differences between these two systems we have compared in table. Of course, MapReduce can be seen as a complement to RDBMS. Yes, it is always a better technology, latest technology than the RDBMS. So certainly we look into the differences. So here is one small, comparative study. Data size. RDBMS. You take any RDBMS, it can handle the data only up to gigabytes. Beyond that, I'm sorry, database RDBMS cannot handle. But MapReduce can go petabytes and beyond. Access, interactive and batch, but here it is only batch wise. And remember one very important thing in traditional RDBMS, you have read write many times. You can read, you can write many times. But in MapReduce, write once and read many times. Once you write, the data cannot be updated at all. So you will going to sense this when you are running a program in MapReduce. When you are running a program in MapReduce. And of course, the schematic structure is static. Here the schema is very dynamic, and integrity is very high, very tightly bounded. All the components here, bounding is very less, and of course scaling, it's a non-scalar, so it has a limitation. Beyond certain number you cannot accept, whereas in MapReduce it is a linear scale. You can add any number of nodes, data nodes, very clearly. And MapReduce good fit for problems that analyze the whole data set in a batch fashion, whereas RDBMS is good for point queries or updates where data set has been ordered, delivered, low latency interval. So we will not suggest MapReduce when the data is less. When the data is less, limited size, so definitely RDBMS is the better option. When we have more and more data, definitely MapReduce is the better option. Okay, and MapReduce suits well for applications where data is written once and read many times. But relational databases are good for both continuous updates. And MapReduce works on semi-structured and unstructured data, but RDBMS works only on structured data. So example of MapReduce, so semi-structured and the unstructured data, textual data, images data, spreadsheet data, etc. So here RDBMS works on database tables, XML docs, etc. Certainly it will support. And MapReduce is designed to interpret data in processing time, the schema on read. So mainly schema to read. So read and analysis. So when you have read and analysis, you can certainly use MapReduce. When you have a lot of data to write and analysis, you can certainly use RDBMS. So normalization creates a problem in Hadoop because it reading the record is a very non-local operation. Instead of Hadoop makes it possible to perform on streaming reading of data. Whereas in RDBMS, data is often normalized to avoid redundancy to retain the integrity. MapReduce can process the data in parallel, but parallel processing is Not true with respect to SQL, RDBMS SQL queries. So these are all the reasons we consider. So when data is huge, certainly MapReduce can be used, and when data is less in size, certainly RDBMS can be used. And when you have more analytics, definitely MapReduce is used. When you have less analytics, your RDBMS is used. And remember one last point: Hadoop system has a Hive, a component called Hive. So are becoming more interactive and adding features like indexing, transitions, that makes it look more like traditional RDBMS. But again, Hive works on Hadoop system, Hadoop ecosystem. So that is one good thing that you should understand. So these are all the comparative studies between RDBMS and MapReduce. So every day what I'm talking, the class, it becomes a answer to major 10 marks question. Yesterday also we spoke a lot of problems and solutions. So that is data flooding, problems and solution. That is one question. The previous day I talked about what is data flooding. That's one question. So for each question, I'm giving the answer. So it is just like I'm indirectly preparing you all, for the examination. And by looking into this situation, I don't know, exams will certainly shoot out once the lockdown is over. So kindly be prepared, keep reading. So prepare your notes at home and read yourself. So you're all in PG studies, post-graduation studies, and you should be able to understand your responsibilities. Hope you all study well and gear up. So that's all for my class. In the next class, we'll be discussing about grid computing and MapReduce, and we'll discuss about voluntary computer. So the entire class recording will be available in this particular website, and also you can see on the study material on this website. So it's over to Arpita. Arpita, are you there?
Yes, sir.
Yeah, please go ahead, Arpita.
Okay.
I'll unshare my screen so you can
Okay.
screen share. Yeah, thank you.
Okay.
It's over to you.
Okay. Is it visible, sir? Sir, is it visible?
Yeah, it's visible. Visible, yes.
Okay. 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 Thank you, sir.
You
Good
play
morning, all.
mobile, yeah, it will run. See, this is a
Yes.
superb, thing. See, some people, had a doubt whether my mobile will work. And of course, she is one example where she's running her slides on mobile. Good, Arpita, go ahead.
I did my presentation through mobile itself, sir, because my laptop had some technical issues yesterday.
Good, Arpita. Please go ahead.
Good morning, all. Today, I'm going to deliver my talk on HDFS, that is Hadoop Distributed File System. Before going to the actual topic, Hadoop Distributed File System, let us understand the term Hadoop. Hadoop is a software programming framework or a platform which is used to store a large amount of data and to perform some computations. Today's agenda is: what is HDFS? Why should we go for HDFS? What are the features or the advantages of HDFS and their limitations? What is HDFS? That here is the formal definition or a technical definition given to Hadoop Distributed File System. That is, the Hadoop Distributed File System is a unique design that provides for extremely large files with streaming data access pattern, and it runs on commodity hardware. Here, the technical terms are extremely large files, streaming data access pattern, and commodity hardware. Let us elaborate these terms. That is extremely large file. Here, we are going to talk about the data size of 1000 TB or 1 PB, which can store a large amount of data. And the second thing is streaming data access pattern, wherein the HDFS has a principle that the data into the files can be written once and read many number of times. That is, write one and read many time principle is followed in HDFS. The third thing is commodity hardware. Commodity hardware is the hardware that is very inexpensive and which are easily available in the market. This is one of the major feature that differs from any other file systems. The below diagram gives you the pictorial representation of HDFS. You could also ask me in which all the operating system where the Hadoop works well. That is Windows and Linux. Windows and Linux both support HDFS.
Arpita, a small update. Due to
Sir?
technical issue, we have to sign out and we have to log in again. Sorry for the interruption.
Okay.
So because it is showing less than 1 minute time, it will get over. So I have to end the meeting and we have to start again. Okay. Kindly, all of you, please sign in again. Please sign in again.